The engineering conference hall in Munich had hosted countless presentations over the decades, but nothing had ever created a reaction quite like this. It was late 2019, and the brightest minds in structural engineering from all across Europe had gathered to discuss the future of sustainable bridge design. Academics, architects, engineers, researchers. Hundreds of them sat in a vast auditorium, filled with hums of conversation, shuffling papers, and the quiet confidence of people who believed they had already mastered the science of building. Then, a Filipino civil engineer, Dr. Maria Reyes, walked onto the stage with a calm, composed presence. She was there to present her research on traditional bamboo bridge construction in the Philippines, a topic she knew would draw skeptical eyes, but even she did not expect how harsh the reaction would be. As soon as the words bamboo engineering appeared on her opening slide, a ripple of snickering moved through the room. Some whispered to each other, others smirked openly. Then one voice, dripping with arrogance, cut through the low chatter. It was Dr. Klaus Hoffmann, Germany's most decorated bridge architect, known across Europe for his concrete megaprojects. He stood abruptly, not waiting for a microphone. "Bamboo," he said loudly, almost laughing. "You're presenting bamboo as a structural material at an international engineering summit? This is embarrassing." He gestured dismissively at her data. "Bamboo is temporary. It rots, it weakens. It fails. That is why we use steel and concrete, because they work." A few others nodded. A French architect spoke up next, raising an eyebrow. "Maybe such materials are acceptable for rural villages, but this conference is about real infrastructure. Real bridges, real loads, real responsibility." The auditorium filled with murmured agreement. Dr. Reyes stood still, her hands gently resting on the podium. She did not snap back, she did not argue. She had expected this reaction long before she arrived. For years, Filipino traditional engineering, particularly bamboo construction, had been dismissed by Western engineers as primitive, as makeshift, as something that had no place in modern structural science. They saw the bamboo bridges of rural Asia as fragile relics, not engineering achievements. What they didn't know was that Dr. Reyes was about to upend everything they thought they understood about materials, sustainability, and structural longevity. She clicked to the next slide and spoke in a calm, steady voice. "Dr. Hoffmann," she said, "what if I told you that in the Philippines there is a bamboo bridge that has stood for over 120 years? Not just standing, thriving, carrying thousands of people every single day, surviving typhoons that have destroyed the concrete bridges around it." Silence fell across the room. Dr. Hoffmann scoffed again, but the confidence behind his voice faltered slightly. "Impossible," he snapped. "Scientifically impossible. Show me the maintenance logs. Show me the inspection reports. Bamboo simply does not last that long under load." Dr. Reyes did not argue. Instead, she offered something he never expected. "Then come to the Philippines," she said. "Bring your entire team, bring your instruments. Examine the bridge yourself. If I am wrong, I will withdraw my entire research. But if I am right," she paused, "then it is time to reconsider everything we think we know about sustainable engineering." A challenge that public could not be ignored. Refusing would mean admitting fear. Accepting would mean risking reputation. So under the eyes of the entire engineering community, Dr. Hoffmann said sharply, "Fine, I will come, and when I prove this is a myth, I expect a formal apology." 3 months later, he and 5 of Germany's top engineers landed in the Philippines armed with high-precision equipment, stress analyzers, moisture meters, ultrasonic testers, advanced load sensors. Everything needed to expose what they assumed would be a structural fraud. From the airport, they traveled through winding provincial roads until they reached a bamboo pedestrian bridge, spanning a deep gorge in Bohol. Locals called it the Bambang Hanging Bridge. When the Germans stepped out of their vehicle and saw the structure, they froze. It looked impossibly delicate, woven bamboo poles bound together with rattan and wooden pegs. "No nails, no bolts, no steel. This?" Dr. Hoffmann said incredulously. "This is your miracle bridge?" Dr. Reyes only smiled politely. An elderly Filipino man approached them. He introduced himself as Mang Thomas, the bridge's caretaker. Dr. Weber, Hoffmann's assistant, asked, "Sir, how long has this bridge been here?" 120 years, the old man replied. "My great-grandfather helped build it. My father cared for it, now I do." Dr. Hoffmann shook his head. "No," he insisted, "that's impossible. Bamboo can't survive that long. You must rebuild it all the time. This must be a replica." The old man laughed softly. No engineer, same bamboo. We know how to choose it, how to cure it, how to place it. Our ancestors understood things your books do not teach. The Germans began their inspection immediately. The first day brought confusion. The bamboo showed almost no rot despite the tropical climate. The joints were surprisingly tight. The structure followed engineering logic they had never studied. Dr. Weber frowned at his readings. The moisture content is perfect, too perfect. Bamboo should be degrading in this humidity, but it isn't. Hoffman refused to accept the results. There must be preservatives. Chemical treatment, something modern. On day 2, they took core samples and brought them to a mobile lab. They analyzed every fiber of rattan binding. They studied the joinery, which used no metal. Just precise craftsmanship passed through generations. Every result contradicted their assumptions. No chemicals, no modern additives, nothing that explained its unbelievable longevity. Instead, they learned the truth from the old caretaker. We smoke the bamboo, he said, with specific woods, specific heat. Then we soak it in a salt mixture made from plants, and we position each pole according to the sun and the winds. Dr. Hoffman brushed it off. That is not engineering, that is superstition. The old man looked at him gently. How long do your modern bridges last? 30 years, 50? Look around. This one has survived more than 100 storms. On day 3, the Germans conducted a full stress test. According to their calculations, the bridge should begin to struggle at around 3,000 kilograms. So they loaded it to 5,000. Nothing happened, then 7,000. Still stable, then 10,000 kilograms, far beyond what bamboo should endure. The bridge barely flexed. Dr. Weber stared at his instruments. Klaus, according to every test we have, this bridge should have failed hours ago. Dr. Hoffman stood speechless. His formulas, his textbooks, his certainty, none of it could explain what he was witnessing. Then came day 4. A typhoon swept toward the region and local officials warned them to evacuate. But Hoffman refused. I want to see how it survives real stress. The storm struck with brutal force. Winds howled, rain hammered the gorge. The river below raged violently. From a reinforced shelter, the German engineers watched the bridge sway, bending with the storm rather than resisting it. It's dancing with the wind, Dr. Weber whispered. It understands the storm, it doesn't fight it. When the typhoon passed, the bamboo bridge stood perfectly intact. Meanwhile, concrete structures kilometers away were cracked, twisted, or destroyed. The next morning, Dr. Hoffman walked across the bridge slowly, touching its handrails with something close to reverence. His arrogance had disappeared completely. I don't understand, he admitted to the old caretaker. I have studied engineering for 30 years. I have built bridges across continents, and I cannot explain this. The caretaker placed a hand on the bamboo railing. That is because you were taught that engineering must conquer nature. Our ancestors believed the opposite. You work with nature, you listen to it. Only then does the material show its strength. The German team stayed 3 more days documenting everything. They photographed the joinery. They recorded interviews. They took measurements that would later challenge everything they knew. When they returned to Munich, Dr. Hoffman did something nobody expected. He wrote a paper titled, What a 120-year-old bamboo bridge taught me about engineering humility. He admitted that Western engineering had lost wisdom in its obsession with modern materials. His paper went viral. Universities added indigenous engineering to their curriculum. Sustainable architecture firms reached out to Filipino engineers for guidance. Dr. Reyes became an international speaker, invited to conferences worldwide. Engineering students from MIT, Cambridge, Tokyo, and Singapore traveled to Bohol to study the bridge themselves. Today, bamboo has become a prized material in sustainable architecture. High-rise buildings use it. New suspension bridges adopt Filipino methods. The world finally sees the genius in something once mocked. But the greatest transformation happened in Dr. Hoffman himself. He now teaches a course called Engineering Wisdom. On the first day, he shows his students a photograph of the bamboo bridge and says, This structure taught me that sometimes the oldest solutions are the most advanced. And back in Bohol, Mang Thomas still maintains the bridge as his family always has. When tourists ask about the famous engineers who came to study it, he just smiles. They came to teach us engineering, he says. But in the end, it was the bridge that taught them.